Section 3.2.14. The following data represent the flight time in minutes of a random sample of 7 flights from one city to another city. Here are the numbers. We have 280, 268, 258, 264, 255, 258, and 265. We have a total of 1, 2, 3, 4, 5, 6, 7. We want to compute the range and the sample standard deviation of the flight time. Now to find the range of the flight time, we take the largest data value, which is 288, and subtract the smallest data value, which is 255, to get 25 minutes. So the range is 25 minutes. Now the sample standard deviation S is computed by determining the sum of the squared deviations about the sample mean and dividing this result by n-1 and then taking the square root. So the formula for the sample standard deviation from a sample size of n is the following, where x1, x2, and xn are the n observations in the sample, and x bar is the sample mean. So the first thing we need to do is we need to find the sample mean of the data that's given. And we know that there's n equals 7 observations. So to find the sample mean being x bar, we add up the 7 observations and then divide it by 7. And therefore, x bar, meaning the sample mean, is 264 minutes. Now that we have the sample mean, we can then compute the deviation about the mean for each data value, taking each data value and then subtracting the mean, and then we're going to square that result. So you can see here that the first data value is 268, the sample mean is 264. When we subtract them, we get 16. And then we're going to square that deviation by taking 16 squared, which gives us 256. Likewise, we got 268. The next data value, subtract the mean, which is 264. We get 4. When we square 4, we get 16. Next, we take 258, the third data value, subtract 264, which gives us negative 6. When we square negative 6, we get positive 36. We take 264, which is the fourth data value, subtract 264, which gives us 0. 0 squared is 0. 255 minus 264 gives us negative 9. Negative 9 squared is positive 81. 258 minus 264 gives us negative 6. Negative 6 squared is positive 36. And 265 minus 264 gives us 1, and then 1 squared is 1. So now what we want to do is we want to be able to then determine what is the sum of the square deviations. We want to add up all these to get the squared sum. So if we take 256, add 16, add 36, add 0, add 81, add 36 and 1, that's going to give us a total of 426. So back up to this formula, we take the sum of the squared deviation about the mean, and then we're going to divide it by n and then subtract 1. Well, here's our formula. S is going to equal the square root of 426 divided by 7 minus 1, which gives us a square root of 71. And rounding it to 1 decimal place, we get the sample standard deviation to be 8.4. Thus, the sample standard deviation of flight time is approximately 8.4 minutes.